Okay, in the last segment, we talked about arguments, non-arguments, and logic. What I'd like to do now is talk about argument structure and argument meaning, because these are really important as we move forward in our discussion about logic. Ultimately, what we're interested in this class is the study of argument structure. As I said last time, I made this comparison between logic and the study of formal grammar of natural language. Okay? Argument structure is really important to understand. So let me begin with an example, as this is probably the best way to get into this topic of structure. Look at the following argument. It's a simple one. It's called a syllogism. All whales are mammals. All mammals are warm-blooded. And the line indicates what we call an inference or an implication. We say, therefore, all whales are warm-blooded. Now, all of us have an intuitive sense of the structure of this particular argument. Okay? All one thing or something else, all that second thing or something else, and so on. It is similar to this particular argument, and you'll see how in just a moment. All squares are triangles. All triangles are rectangles. So, all squares are rectangles. This says rectangles if you can't read it. Okay. Now, there's a difference, of course, between these two arguments. The first one is an argument that you would accept, and the second one is an argument that you would reject. But there's something similar between the two, and I'm going to draw that similarity out on this second board. Both arguments have an underlying structure of the following form. All F are G, all G are H, therefore all F are H. Each of these letters stands for a particular term in natural language, like whales, mammals, squares, triangles. Okay, you can substitute in all sorts of different things for F, G, and H. We could talk about ducks. All ducks are friendly. All friendly things bark, so all ducks bark. I mean, it doesn't matter what we substitute in. We get the sense that there's an underlying structure, and that structure undergoes what we call an interpretation. Right? We can substitute terms in for F, G, and H to produce real-world arguments. Some of those arguments we find convincing. Some of those arguments we accept. Others we don't, okay? Because their interpretation simply doesn't fit with what we know is true about the world. We know that all whales are mammals. We know that all mammals are warm-blooded, and we know that all whales are warm-blooded. Right? Logic is the study of the underlying structure of arguments like this. Now, the way we want to distinguish structure from meaning is this. We want to say that structure is, if you like, the underlying grammar of the argument. We study forms of statements and their relationships, as are indicated here. Interpretation is really about meaning. When we substitute in whales for F, mammals for G, and warm-blooded things for the other term, then we're dealing with interpretation and meaning. Okay? But we can study this as a mathematical object, separate from what's going on in the actual world. Right? So structure and meaning is an important distinction in the study of logic. This is like the grammar of language. We can study it on its own. We can determine whether or not certain argument forms are good ones. We happen to have here an argument form which we call a valid form. And what that means is that if these two claims are true, the following claim must be true also. The conclusion must be true also. Okay? If all whales are mammals and all mammals are warm-blooded, it's necessarily the case that all whales are warm-blooded. Now, notice this as well. If all squares are triangles and all triangles are rectangles, it would have to follow logically that all squares are rectangles. The reason we reject this argument but accept that one is because in the real world, these claims are false, whereas these claims are true. Okay? All right, so that gives you a sense of structure versus meaning.